Hi guys, Fred here, AF Math and Engineering. Moving along in our integral section. So in the last video we did definite integrals, and definite integrals were ones where we had numbers on the top and bottom of the integral sign, which meant that we were evaluating the integral on some range on the x-axis. So we were trying, or the y, it could be the y, but we're trying to find a specific chunk of a function, the area under that curve. Now what we're doing is we're finding the general form of an integral. So as you can notice in these two questions, we don't have any bounds here on the top and the bottom, right? So that is what we're going to start with, and I'm also going to introduce to you the concept of U-substitution. So U-substitution can be quite confusing. I think that's one of the much trickier parts when this U-substitution comes in. People start to get a little bit confused and they're not sure, okay, what do I substitute? And you know, there are choices now on what we can substitute in, right? So all I can tell you is that practice is going to be your number one tool in overcoming those issues and knowing what to substitute and what different questions, you know, the tricks there are in them. Just do lots and lots of problems in your book. But hopefully we can explain to you at least the idea of what this is in these two questions, and you know, give you a good starting basis. Okay. So with that being said, let's get started, and I'll get to U-substitution and what it is throughout this first question, okay? So the first question, we're asked to solve e to the u over 1 minus e to the u squared du, okay? So this is a little bit of a trick because, you know, you're used to using U-substitution, right? So you use u as your variable when you substitute, but there's already u in this equation, right? So it doesn't matter what you substitute with. You can use r or, you know, z or anything you want, okay? But just for the sake of simplicity here, we'll keep everything the same. I'm just going to change this u variable to x. That's something that you can do if you come across this in an exam. Obviously, changing u to x here doesn't really change anything in the question. It just helps us not get confused as much. Okay, so let's get started. So as we can see on the bottom here, okay, we have this integral, and we can't just evaluate it like this. I mean, we can't use the power rule or anything. It's kind of messy. But I do see on the bottom we have this 1 minus e to the x term, okay? And let's go ahead and substitute that for u, okay? And we'll see where that gets us, all right? So let's say that this term here, 1 minus e to the x, not the square, but just what's inside the bracket, is equal to u. Okay, so let's go ahead and do that here on the right. So I'll say that u is equal to 1 minus e to the x. Perfect. So now with u substitution, what we're going to go ahead and do is we're going to differentiate u with respect to x, okay? And we'll see what we get here. So we'll say that du, okay, is equal to, and let's take the derivative of the right side with respect to x. So derivative of 1 is just 0. And the derivative of negative e to the x is, well, that's negative e to the x. So negative e to the x, that doesn't change. And then we're just going to write dx here, okay? So that would be the same thing as saying du by dx is equal to 1 minus e to the x, right? But we just took the dx and we moved it to the other side. Perfect. Okay, so, well, how do we proceed here? Let's rewrite this equation with our u in there. So we have e to the x over u squared dx, right? So when we're doing u substitution, there's two little tricks that we want to look for. One, we want to substitute something so that it's going to cancel something in the equation so that we're left with only one variable, right? Because in this equation here, in this expression, we have an x variable, and a u variable, right? So we can't really operate on this function until we have the function as a product of just one variable, one type of variable. So we want to cancel this x out. We want to get rid of the x. Okay, so how we're going to do that, all right, is we're going to rearrange this equation here and substitute for dx. Okay, so that's really where the tricky part comes in with substitution, is knowing how to do that. So let's go ahead and solve for dx here in this equation. So I'm going to bring that down here. So dx, okay, is equal, I'm just going to divide both sides by negative e to the x. So we have du over negative e to the x, okay? And if you'll see now, if we plug dx into our equation here, all right, I'm going to write that down here. I'm plugging dx in here, so I'm plugging du over negative e to the x. All right, well, you'll see that e to the x cancels here, right? And, well, that's really good for us because now what we have is we have an expression with just u du. And we can evaluate that, and it's a much more simple integral. So as you can see, what we did is we took a messy integral here, we used U-substitution, and we made it much more simple. And by doing that, we can now solve it. So let's take this negative sign. We still have that negative, don't forget to carry that. Let's move it outside of the integral, and we're left with 1 over u squared du. Perfect. Okay, so let's come up here, and let me just circle this, square this part with purple, all right? That's not part of the question necessarily. I mean, it is, but it's not part of what we're solving here, so I'll just keep that separate. So we're at negative 1 over u squared du, right? So this is an integral that we've solved in a previous video. Let's go ahead and solve it. So we'll bring that u to the top, and we'll make the exponent negative. Perfect. And, well, now we can evaluate this as a very simple integral. So we have u to the n plus 1 over n plus 1, right? So negative 2 plus 1 is negative 1, okay? So we have negative. All right, we have u to the n plus 1, so u to the negative 1. And we're just also going to divide the u by negative 1, right? Perfect. And we're also not going to forget our plus c, but we're just going to write that in at the end, okay? All right, so now we can go ahead and cancel these negatives here, right? And we're left with 1 over u, right? So just move that u back to the bottom. All right, perfect. So now our last step in any equation like this, or any question like this, is to go ahead and plug our u back in at the end. Now, if this was a definite integral with substitution, we would need to reevaluate our bounds before we did this step, okay? But we're going to get to that in another video. For now, all you need to do at this point is u here, okay? That needs to go back into the equation, all right? So we're going to take this, and we're going to go back into the equation, and we have 1 over 1 minus e to the x, okay? And we're now going to add our plus c there, and that is it, okay? So I hope that was helpful in just giving you the basics about U-substitution. Let's try another one. Let's go to question 2. We have the integration of sine, and inside the argument we have pi x dx. Okay, so how do we go about solving this? As we can see here, we have a constant inside of the argument of sine, and this is a prime example of another case where we're going to have to apply a U-substitution in order to go ahead and evaluate this, because otherwise we can't really do it, right? So inside the argument, let's go ahead and let's substitute that out, so we have a nice simple function of sine u, which we can then go ahead and integrate. So down here, I'm just going to say, actually I'll do it over here on the right, we'll say that u is equal to pi x, okay? And du, all right, differentiating u with respect to x, okay? So we're differentiating this with respect to x. The x just goes away, right? And we're left with the constant, which is pi dx. Perfect. Okay, so how does that help us here? Well, if we go ahead and bring this down here and rewrite it as sine u dx, all right, let's do exactly what we did in the last question, is let's solve for dx, and we're going to substitute that into this equation, okay? So dx is equal to du over pi, right? We're just dividing both sides by pi. And now we can go ahead and substitute dx directly in to this equation here. So I'll just draw an arrow over here. And we have sine u times du over pi. Perfect. So that looks like something that we can easily evaluate, right? We worked on this before. So and remember, when we're working with indefinite integrals and integrals in general, a good idea is to take this constant and just move it to the outside of the integral, okay? Because it doesn't affect at all how the function is integrated, but it does get confusing when you have longer integrals and all the constants are still in there. So it's best just to group them all up and move them to the outside as you work. So that's what we're going to do here. We're going to take this 1 over pi, we're going to move it to the outside of the equation. All right, and we are left with sine u du. And you know, let's go ahead and evaluate that integral. There's not much more to that. We know that the integral of sine u is negative cos u. So, okay. And remembering our plus c, we're not forgetting it, we're just going to put it in at the end, okay? So, well, what do we have here? That's negative cos u over pi. And well, what's the next step? You guys can probably just call it out right now, but it's exactly the same thing that we did in the last question. We're going to substitute u back in to the question, and that is going to give us our final answer. So where's our u? Well, our u, if you remember from our initial substitution, was pi x. So let's go ahead and put that back in. So we have cosine pi x over pi. Perfect. And that is our answer, guys. Okay, so don't be scared with U-substitution. I know it seems tricky, but I hope these questions gave you a little bit of a foundation of what U-substitution is, and a couple of the examples of how it's applied. Go to your books, do all the U-substitution problems you can, because the exam questions are going to be tricky. All right, we'll try and maybe get to an exam level question in another video, something really, really tricky, but you know, just like I said, lots of practice, guys. Thanks for watching. Like and subscribe if you enjoyed this video.